We have a rational inequality to solve. We'll state our answer in interval notation and we'll also graph the answer on a real number line. We have 2x plus 1 over x minus 3 is less than or equal to 3. Well, the first step we want to do is get one side equal to 0. So let's subtract 3 from both sides of this inequality. So we have 2x plus 1 over x minus 3 minus 3 is less than or equal to 0. Now, we want to make sure that we have a common denominator to combine these two terms on the left-hand side. So our common denominator will be x minus 3. So I'll multiply the second term by x minus 3 over x minus 3 to get the common denominator. Now I can write the left-hand side as a denominator of x minus 3. The numerator will be 2x plus 1 minus 3 times the quantity x minus 3. And this is less than or equal to 0. Let's simplify, and we get 2x plus 1 minus 3x plus 9 over x minus 3 is less than or equal to 0. In the numerator, we get negative x plus 10 over x minus 3 is less than or equal to 0. Now, this was all a part of step 1. We wanted to make sure that we had all of our terms on one side and 0 on the other side. Now we're ready to move on to step 2. In step 2, we set both the numerator and the denominator equal to 0 to get partition values. If we set negative x plus 10 equal to 0 and we solve this, we get a solution of x equals 10. If we set x minus 3 equal to 0 and solve it, we get a solution of x equals 3. Let's move on now to step 3. In step 3, we'll create a number line with these two partition values. The two partition values are 3 and 10. We have 3 different intervals now. We have an interval to the left of 3, we have an interval between 3 and 10, and also to the right of 10. In step 4, we're going to choose a value from each interval. So first, let's let x equal a value less than 3. We can choose 0 and we can find our function value now. So if we let x equal 0, let's substitute it right down here where I have the arrow. If we substitute 0 in for x, we'd have 0 plus 10 over 0 minus 3. That would be 10 over negative 3, or a negative function value. We can choose a value between 3 and 10 for x. Let's say 4. If we substitute 4 in for x, we get negative 4 plus 10, which is 6, over 4 minus 3, which is 1, which is a positive function value. And then we'll choose a value to the right of 10. Say x equals 11. We have negative 11 plus 10, which is negative 1, over 11 minus 3, which is 8. That's a negative value. Now, let's look at what we're being asked. We want to know when is negative x plus 10 over x minus 3 less than or equal to 0. So when is it 0 or a negative number? Well, it's going to be 0 at any of these partition points, and it'll be a negative number anytime we ended up with a negative sign for our function value. So now we're ready to actually write our solution in number 5 on a number line, and then finally in interval notation. So we have 0, 1, 2, 3. And there's our number line from 0 to 10. So we're ready to graph our solution. We know that this function is less than or equal to 0 in the interval from 3 and to the left of 3. But let's be very careful before we actually graph this. Let's go back to the original function. Notice we have x minus 3 in the denominator. It's very important to look at the domain of this rational function. So our domain is such that x cannot be equal to 3, because if I substitute 3 in for x, that would give me 0 in the denominator. Now, when I write the solution, normally I will use brackets because my original inequality has a less than or equal to. However, I have to be careful. I cannot use a bracket on 3 because x cannot equal 3. So when I look at the interval to the left of 3, I want to use a parenthesis, so I'm excluding 3 as a possible solution. We also have the union with 10 to infinity as a possible solution because we have negative function values there as well. So from 10, I will use a bracket and I will put an arrow to the right of 10. This is my number line solution. The interval notation will be from negative infinity up to open interval 3, union from closed 10 to positive infinity.